I'm Jeff Yarger. I'm a professor of chemistry, biochemistry, and physics at Arizona State University. I've created a series of lecture notes, and I'm here today to introduce the second in this series of notes, lecture note set number 2. And in this lecture note series, I give a title that introduces the various topics that are covered in this one. And basically, while the first set of lecture notes introduced a lot of the concepts associated with the first law of thermodynamics, the vernacular and vocabulary used in thermodynamics, etc., this one continues on, introduces the second law, and probably one of the most important concepts in thermodynamics, which is entropy. In fact, you could summarize this entire set of lecture notes as introducing and using entropy in chemical and biochemical processes as examples of thermodynamics and its usefulness. However, at the same time, besides looking quite extensively at entropy, we also relate this to the extremum principles, to maximum work functions, and then we also cover very explicitly the mathematics, the calculus and partial derivative mathematics needed and used in thermodynamics explicitly, looking at, for example, partial derivative Maxwell relations, because the systems we're looking at, the total derivative systems we're looking at, are total derivative or exact differentials. And so that comes with some consequences that we can use to relate variables, etc. So at the end of this lecture note, hopefully you'll have a good sense for entropy and its relationship in thermodynamics. And this lecture note gives several examples of using it in both chemistry and biochemical systems. Thank you.